Hey there, everyone. Ryan Schul here with Straight Data Science. So today I want to talk about using Monte Carlo simulations to assess capital adequacy. So what does this mean? Basically, in corporate finance, we want to understand if we make an investment in some type of project or business or other entity or whatever it is, what kind of cash flows can we expect from this transaction, from this enterprise, and then how profitable will it be? Okay, so we're going to do a Monte Carlo simulation to understand and create multiple different scenarios. I'm going to do about 10,000 different simulations here and understand the probabilities of different outcomes and see most likely what the ultimate objective will be, right? Because when you make an investment, you'll know, is it going to pay off huge? Is it going to pay off minimum? Is it going to be something in between? We just don't know what's going to happen ultimately, but we can do simulations or do a statistical analysis to try to understand what the probabilities of different outcomes can be. Okay, so given all the uncertainty in the business world, and it's been like this forever, the world is on fire right now. It's 2025 and everything is burning down. You can see it. Just put the news on, right? You can see it. But there's always some uncertainty in the business world. We want consistency and persistency, right? Those are the things that we're looking for. But you don't really get that, but you can kind of manufacture that or create that for yourself. And this helps with making risk-based decision, right? Capital allocation with confidence. Like how much confidence do we have with this? Do we have to set up some guardrails? Do we have to, set up some limitations or some kind of parameters here for our capital allocation. So we're just trying to understand how we can use capital better. We want capital creation, not capital destruction, right? So we can stress test different scenarios or stress test different assumptions. And investors, CFOs, we can get credibility from the board and just make better informed, intelligent decisions based on this scenario analysis and this simulation analysis. That's what we're doing here. So if you understand finance, that's great. You're going to understand this, and everything will pretty much make sense. And if you're not a financial expert, that's totally fine. That's totally fine. Let me take you through it and let me walk you through. We'll do baby steps here, okay? So we are going to set the number of years up to 10, the number of simulations to 10,000. So the computer is going to run 10,000 random simulations, and based on the inputs that I feed to the computer, we're going to see what the potential outcome is going to be. So we have initial revenue of $10 million. The revenue growth mean is average in the statistics world. We call it mean. It's basically an average. So higher is better in this. Obviously, like the higher the revenue, the better off you're going to be. And the standard deviation of the growth of the business, lower is actually better. So if you have a little bit of growth and it's consistent and persistent, that's great. If you have huge wild swings and deviations, you see this a lot in startups, that's not so great, right? We want some growth, but lower is better. Gross margin is basically what the company keeps before operating costs, taxes, and reinvestment and things like that. So you want higher margins, bigger is better. Operating margin, kind of the same thing, right? More profits per dollar. This is basically operating income divided by revenue. So bigger is better. CapEx, this is the capital expenditure for this project, right? So if you invest in a project, you have certain startup costs. Maybe the perfect project would be, okay, I invest $1 million or whatever, and it pays me $1 million back, right? There's no overhead, there's no operating costs, there's no taxes, but that's like kind of like a fairy tale, right? It doesn't really work like that. There's always cost of doing business, cost of goods sold, COGS, COGS, cost of goods sold. They always cost something to run your business, right? At least you have to pay your employees. You have to pay your employees to do something. So there's always a cost to do business, right? So it's always CapEx, um, or I'm sorry, yeah, CapEx percent, okay, and then we have the working capital percent. So this is current assets minus current liabilities. That's the working capital. So how much working capital you have after you pay off all your liabilities? What's left? What's the remainder or left over for the assets? Okay, so the discount rate is basically the interest rate. The interest rate you would pay on your credit card or on your mortgage. Discount rate is the interest rate, and we have a terminal growth This is how much the business ends up with at the end of the 10-year period. And these are all parameters I'm putting in, right? So you can set this up to be anything you want. I like this um, this project a lot because you have the ability to change all these parameters. You can put in you can put in whatever you want and change this around. You can change this around to match your specific scenario, right? So it's very dynamic, very interactive, and all these inputs are whatever you need it to be, right? Like this is just a hypothetical that I came up with and I created, but you would change your inputs to match whatever asset you're investing in or whatever project you're investing in, and then understand the cash flows and how lucrative this is going to be and what kind of profit you're going to make on this. So with the Monte Carlo simulation, we're going to run a bunch of simulations right here for sim and range simulations. The simulation right here is 10,000. If I do Control F, you can see that right here. Simulations is 10,000. And this can be anything. For I, a lot of times you do I and range, sim, it can be anything you want. Like when in the Python world, you define your variables, right, when you're looping through. And then we're going to create cash flows and we're going to append these, the results to this list right here. So anything with a square bracket in Python is a list. If you have the curly brackets, it's a tuple. And if you have a dictionary, you'll have a key value pair. So there's like four basic structures in Python. Maybe there's more, I'm not even sure, but those are the four that I've used. And you can have a data frame too. So the list and the data frame was what I use mostly. There's a tuple and there is a dictionary too, which have key value pairs. And there's pros and cons to using all of this, okay? So I'm going to go ahead, run all these simulations randomly, right, and see what the outcome is, and everything is going to be appended. Where was that? Where was that? Results. Cash flow. Give me a second here. Let me see this thing. Control F. Yep. Cash flow append. Oh yeah, those are the free cash flows. That's what we came up with. So here's the math here. We're doing the growth rate, the revenue, gross profit, operating income, capex, change, the taxes, right? We have to take out taxes from all these transactions and we come up with the free cash flow. The whole point of this whole case study right here is to allow you to input your specific numbers into this scenario, and then you can understand how profitable or how not profitable your project is going to be, and is your investment going to pay off or not. And we do the simulation using Monte Carlo methodology to understand the probability of these different payoffs. Because I can't say what's going to happen 10 years from now. Nobody knows that. I can't know that. You don't know that. Nobody knows that, right? I can't even say what's going to happen even 10 hours from now. I don't know what's going to happen 10 hours into the future, maybe even 10 minutes, right? So I don't know this, but we can set up an analysis to do a simulation and understand the probabilities of what the potential outcome can be. Right? So I'm going to go ahead and run this right here, and let's see what the computer comes back at. Okay, so we invested 10 million, right? We did 10,000 scenarios. These are the inputs right here: revenue, revenue growth, margins, operating capex, working capital discount, and the terminal growth in the taxes are going to be about 25%. So this is probably the one thing you can know, like 25%, or I think 35% is the other corporate tax rate. That might have changed. I know that's what it used to be. So these are kind of given. This one is a little bit arbitrary too. You have to understand what the terminal is going to be, and then all of these other inputs are whatever you want it to be, right? So it's very, very dynamic, very interactive. And if we invest $10 million, 10 years from now, we have $58 million. That's the mean net present value. What's NPV? It's basically a way of measuring the value of an asset that has cash flows, right? You invest in a certain business. It can be anything. You can buy a gas station. You can buy a grocery store. You can buy um, daycare, babysitting business, or whatever, right? Like you would input all of your um, whatever variables, right? And then you see how profitable that business is going to be over time. So the investment here was 10,000, and after 10 years, you have 58,000. The median is going to be 54,000. The fifth percentile is 26,000, and the 95th percentile. So this is like the almost the worst case scenario, and this is the best case scenario. So if you invest 10 million, you can have 103,000. But is that really going to happen? Probably not, but it could happen. You could have 103,000. But probably the worst case scenario, based on the estimates that we gave the model, is going to be 27,000, right? So the mean NPV on average is the investment that's expected to create around, whatever you put into it. Okay, think of this as the best guess. The median should be pretty close to the mean. They should be pretty much aligned. And if they're not, then um, then something might be a little bit off with your analysis, with your assumptions or something like that. But these two should line up. If they line up, that's fine. In most cases, they will be pretty close. If it's not, you probably have to reconsider your assumptions or look a little bit closer at that. So the fifth percentile is only 5% of the scenarios were worse than this. So even if you invested $10 million, like 95% of the time it's going to make at least 27,000 or more, and the probably the best case scenario is 103,000. So it's 10 times your investment, right? You invest 10 million, you make 100 million after 10 years, but that's the cost of doing business, and that's the time value of money, right? You lock up your investment for 10 years, you should have some kind of payoff, right? So you'll make 100,000, 100 million in this case, but it took 10 million to get to that 100 million, right? And we're 95% confident that it's going to be that number or less, okay? And then we can plot the results here, Control Enter to refresh the chart, okay? And the median and the mean NPVs are pretty close to each other, right? The net present value is 56 to 58, all right? If I can zoom in here, this is a Plotly chart, so the median would be, put my mouse over that, median would be about 56 to 320. Oh no, 54 to 56. That's it. And there's about 320 counts of returns from this Monte Carlo simulation. And the median, or the mean, sorry, the mean would be 58 to 60. Okay, so we're pretty much aligned there. So that is just one scenario. But again, like if you change these assumptions to match your specific scenario, that's what this model is designed to do. So maybe this is definitely profitable. I would invest in this business. I don't have $10 million sitting around in my bank account, but if I did, I would definitely invest in this business. I could have up to 103. Was that the thing? 103,000 at the end of 10 years. The probably worst case scenario could go lower. I mean, it could go bankrupt and go out of business, but it's highly unlikely given the assumptions that we have. The worst case scenario would have 27 million, so about what would that be? You'd make 17 million, right? Like 27 minus 10 is 17. So you still make 17 million in 10 years. But the point is also you have to make these assumptions realistic. If your revenue growth is less, okay, higher is better. If this is more like 10 instead of 15 and standard deviation, I can leave it alone. I can leave that. If gross margins is less, let me put that at 0.3 instead of 0.5. Operating margin, maybe 0.4, right? So maybe it costs more to run this business. Maybe the margins are a little bit lower and we're not getting as much bang for the buck. And let me say the discount rate instead of 5% is 10%. Remember, this is the interest that we would pay on the loan for this money. So if you change the assumptions, then the outcome is going to change too, right? So now we have negative 9 million, right? So I'm not going to invest in this. And the median is negative 8, fifth percentile negative, and let me refresh the chart. Control Enter to run it. And yeah, now we can lose up to 25 million. And the best case scenario maybe is make 3 million in this case, but that's only because we changed the assumptions, right? Now the revenue is much lower, the cost of doing business is much greater, the margins are greater, and the cost of borrowing the money is much higher, right? So let me make one more assumption here. Let me change this again. So let's say I think interest rates are about 0.8% for a mortgage in New York City in 2025. If the operating margins are better, let's boost this up and boost this up to 0.6 and then just say revenue growth. The revenue growth is 0.15. And again, it's all based on your scenario. So it's very dynamic. I can't anticipate what your business is going to do. I can't tell you what to do. Only you know that, right? But I'm trying to make this very dynamic and do a Monte Carlo simulation so we can test lots and lots and lots of different scenarios and ultimately see what is the probability of different outcomes and then make an assessment and make a judgment about this specific investment. So I changed a couple of assumptions. We had negative 9 million Let me hit Control Enter to refresh this. And what does the model come back with? 64 million. Okay, so now we invest 9 million. I'm sorry, 10 million, and we made 64 million. So this is a good investment, right? So the best case scenario would be about 111 million, worst case 32 million. But again, it all comes down to these, right? These variables will change based on your specific scenario. So you have to put in whatever is realistic to your business, okay? And then the model will do all these simulation analyses and spit out a final number of what the probability will be for you to be profitable with your investment or your business or whatever it is you're doing. There's the chart. We can make up to 200 million, right? And worst case scenario is down here about 20 million on a $10 million investment. So that's it. If hopefully you understand this or it resonates with you at least a little bit, hopefully it sparks an interest. If not, do some research, do some Googling on corporate finance. People do this all the time in the corporate finance domain. And it just gives you more insight and more like vision, a greater vision into the potential of what could actually occur with your investments, right? That's the whole point here. So we're trying to make make a forecast into the future and understand the probability of certain outcomes. That's what this is, okay? So I will save all the code when I post this video. I'll share with you. You have everything you need. All you have to do is change these inputs, hit Control Enter to run this in your Jupyter notebook. And again, make it very relevant, very specific to your specific business and your operations and whatever it is that you're doing to generate cash flows. And the Monte Carlo simulator will spit out the report and the output, okay? And you can interpret that and decide, is this a good investment or is this a bad investment, right? So you have to do a little homework. You have to do the labor and make the effort to set this up. But once you change these variables, the simulator will do the rest of the work, will do the whole lift, and you get your results. And yes, this is a thumbs up decision. We're going to be profitable, or a thumbs down, and we're not going to be profitable. Okay. So that's it. Just wanted to set you up with that for success. So thank you for your time today. Hopefully this was informative and educational. I'm going to wrap it up right here, and I will see you in the next video. Goodbye for now.